Hello children. So in the previous videos we have covered a topic for cellular respiration, and in this video I'm going to talk about a very small topic that is left regarding cellular respiration, that is respiratory quotient, which is also abbreviated as RQ. Okay, so what exactly is this respiratory quotient? Okay, so respiratory quotient is defined as, or this RQ is defined as, the ratio of volume of carbon dioxide that is getting released or evolved by volume of oxygen that is getting absorbed during respiration during respiration. Okay, so what exactly is RQ? That it is a ratio of volume of carbon dioxide that is getting released to the volume of oxygen that is getting absorbed during respiration. As we know, during respiration reaction, the oxygen is getting utilized or absorbed, and carbon dioxide is going to get released. So it is just a ratio of volume of carbon dioxide evolved to the volume of oxygen absorbed during respiration. Now this RQ can be calculated for like different substrate, and it is different for different substrates. So let us just take the example for most commonly used substrate, that is your carbohydrate. And in the case of carbohydrate, precisely I am going to take the example of glucose, the most commonly used respiratory substrate. Okay, so if you consider glucose or the carbohydrate as a respiratory substrate, the chemical reaction will be something like this: C6H12O6, that is your glucose, when combines with 6 molecules of oxygen in the presence of 6 molecules of water, it is going to release 6 molecules of carbon dioxide plus 12 molecules of water and some amount of energy. So this is a balanced reaction for when we are using glucose as a substrate. Okay, so here we are noticing that what is happening: 6 molecules of oxygen are getting absorbed and 6 molecules of carbon dioxide are getting released. So according to the formula, RQ will be equal to volume of CO2 evolved will be 6, while volume of O2 absorbed will also be 6. So ultimately for glucose, the RQ will be 1. It will be equivalent to 1, or they can also write in the form of unity, that for glucose the RQ will be, or for carbohydrate the RQ will be unity, which is equivalent to 1. Okay, now if I take another example like fat, you just need to remember the value. They can ask for like different substrates, so you just need to remember the value for all these substrate. So in the case of fat, or in the case of oil, lipid, basically the RQ will be, the RQ is going to be 0.7. And if it would be the case of protein, then the RQ is going to be 0.9. So in both the cases, it will be less than 1 only. It will be less than 1. So they can they can directly ask you the value of the RQ for protein or for fat, or they can also frame the question in a form like less than 1, more than 1, or equivalent to 1. So in the case of fat as well as protein, the RQ will be less than 1 only, right? Now they can also ask you they can also ask the RQ value in the case of succulents, or they can just frame that in which case the RQ is going to be, 0, in which case the RQ is going to be 0. So please remember, in the case of succulents means your basically xerophytes or the desert plants. What happens, they do not, if you remember from photosynthesis chapter, they do not evolve carbon dioxide during night hours. During night hours. Okay. So in this case, the RQ is going to be 0. Right? Why? Because it will be 0 by some amount of oxygen. So ultimately it is going to be 0. Right? So in the case of circulants, the RQ is going to be 0. And if they ask you RQ is equal to infinity, RQ is equal to infinity. So please remember that will happen in the case of anaerobic respiration. That will happen in the case of anaerobic respiration. Okay. So what happens in the case of anaerobic conditions or anaerobic respiration? There is no utilization of oxygen. So whatever carbon dioxide is getting released, there is no oxygen. It will be 0 of oxygen. So ultimately it will give you infinity. The value will be infinity. Okay. And another case they can ask you, the last case, that is RQ will be more than unity. Means it will be greater than 1. Okay. So this happens in the case when the substrates are organic acid. When the substrates are organic acids like oxalic acid or malic acid. So when the substrates are organic acid, the RQ will be more than unity. Okay. So this was all about respiratory quotient. Please remember that it is the ratio of volume of carbon dioxide that is getting released to the volume of oxygen that is going to get absorbed during respiration. Hope this video clears the concept about respiratory quotient to you, and I'll see you in the next videos then. Bye bye, take care, stay safe.